So in this video, we're simplifying algebraic expressions. And I think the most important start is that we are simplifying, not solving. So when you're simplifying something, you're cleaning it up. I like to think of it that you're combining your like terms. You're paying attention to those rules that we learned with PEMDAS. You're just kind of making it look better. When you're asked to solve an equation, that's when you have like x equals, y equals, or some variable equals. You're looking for what something equals. When simplifying, you're not. You're just cleaning it up and combining what will hang out with one another. So, for example, if we had some problem that was like 10x minus 9 plus 8 minus 2x plus 4, with these we look at it and we're like, okay, well, who will hang out with each other? And if you see here, the 10x will hang out with the negative 2x. If I have 10 and I take away 2, right? Adding a negative is the same as subtracting. So I have a total of 8x's. And then my negative 9 and my 8 will hang out with one another. They're both constants. So negative 9 plus 8 is negative 1. And then the 4y here doesn't have anyone else like it. So it's just going to be 4y. And that's as far as we can take it. That is simplified. We can't go any further. They won't hang out with each other because they're not like terms. So next example, if we have something a little more complex, we'll bring in our good old friend, the distributive property. Remember, the parentheses mean that this is 3 times the entire thing in here. You need to multiply it by everything in the parentheses. So you go 3 times the 5x and 3 times the negative 6. That's what the parentheses are telling you to do, is multiply this by everything inside of here. So we get 15x minus 18 plus 4x. That's the first step. Get rid of your parentheses. Now combine your like terms. Well, the 15x and the 4x both have x's, so they'll hang out with each other. We can combine them. So we get 19x minus the 18. And that's the final answer, because x won't hang out with the 18. He's like, I have an x and you don't. We're not hanging out. Next one. What if we do something like this? Now, most people, the most common mistake I see is made right here with this. Everyone's like, okay, I'm going to get rid of my parentheses and everything goes great. But this minus here, it's really a negative 1 that we don't write. Mathematicians often don't write things that clutter up. So they're assuming you know that's a negative 1 that has to get distributed to both of these things. And that's where people make the mistake. Sometimes they'll distribute it to the first one, but not to the second one. So Q, you're going to do distributive property twice. So we will get 12x minus 6 minus 4x minus 3. Be very careful about your negative signs here. 12x and negative 4x will hang out to make 8x. The negative 6 and the negative 3 hang out to make negative 9. And there's your final answer. Let's do another one. 5x times x plus 2 minus x. See, sometimes they're nice and they'll put something there, but don't depend on that. If there's nothing there, there's a 1 there, like we did here. But this time they were nice and they put something there. So negative x is going to get multiplied by the 3x. It's also going to get multiplied by the negative 4. So x times x, hopefully you're like, oh yeah, that's x squared. So this is 5x squared plus 10x minus 3x squared, because the x times the x. And then the 4 doesn't have an x, and we have a negative times a negative, making a positive 4x. Now, the x squareds will hang out with one another. So we end up with 2x squared, and this 10x here will hang out with the 4x plus 14x.